Hello students, today we're going to continue section 9.2. We're going to finish up talking about hyperbolas. So last new formula thing we got to talk about for hyperbolas is we can also measure the eccentricity of a hyperbola. And the formula for eccentricity is the same. It is c divided by a. Now for a hyperbola, it's always going to be a number that's larger than 1 because in a hyperbola, the distance of c is always bigger than the distance of a. Now, if the value is very close to 1, though, the hyperbola will be like really stretched out in a really wide curve. This would be an example of an eccentricity of 9/8. As you get farther and farther from 1, though, so the bigger the eccentricity is, the more stretched out or compressed. I guess compressed maybe would be the word for that. The hyperbola as the curve gets closer together. Now, one thing though I wanted to mention though is if you know the eccentricity, so if I tell you that E is 4/3, what are the values of C and A? Now, one thing I wanted to mention here is that just because the formula is C over A and C over A is 4/3, does that mean that C is 4 and A is 3? Well, not necessarily. That's just one possibility because there's actually a lot of combos that would simplify to 4/3. For example, C could be 8 and A could be 6 because when you do 8/6, that simplifies to 4/3. And you can imagine there's a whole bunch of combinations that would give you 4/3. Could be 40 over 30 or 12 over 9 or, really anything. So just because you know the eccentricity doesn't mean that this is C and this is A. All right, so let's take a look at some examples here. We're going to be doing problems today where you're given some information about the hyperbola, and then based on what you know, you have to graph it and write the equation for it. So let's say there's a hyperbola with an eccentricity of 5/3, and the foci are at 10, 0, and -10, 0. And let's graph this hyperbola. So basically what you're going to want to do is start with basically this. Which of these three values do you know? A, B, and C. So because the foci are 10, 0, and -10, 0, those points are 20 units apart. The center would be right in the middle of them at 0, 0, which means each one of these would be 10 units away from the center. That means C is 10. And then I don't know the values of A and B. So then I'm going to use my formula for eccentricity. So that's E equals 5/3. And I know the formula is E equals C over A. And I plug in the value I know for C is 10 and E is 5/3. So I've got 5/3 equals 10 over A. And then I can solve this equation, or you can scale up this fraction. But either way, you get that A is 6. Okay, so then we would know using that formula that A is 6. Once you know two of these three values, you can find the third one using this formula for a hyperbola. A squared plus B squared equals C squared. So A is 6, C is 10, and you solve and you get that B is 8. And now you know A, B, and C, and now you can graph the hyperbola. So I start with the foci at 10 and -10. The center will be halfway between at 0, 0. Since A is 6 and the foci are left and right of each other, that means A will go horizontal because A is called the transverse axis, which has the vertices on it, and those will always be in the same direction from the center as the foci are. So in the horizontal direction, I move 6 units to the left and right of the center. And then since B is 8, I move 8 units above and below the center. I use those 4 points to draw this rectangle. I then draw the asymptotes through the corners of that rectangle and through the center. And then because the foci are left and right of each other, I know the hyperbola is going to open left and right. So I draw that curve inside those dotted lines. And then from here, I can write the equation. It's centered at 0, 0, so that's an x squared and a y squared in the top. In the x direction, that's a stretch of 6. Y direction is a stretch of 8. So 6 squared goes underneath x squared, and 8 squared goes underneath y squared. Pay attention though to the order of your subtraction. I put x first because it opens to the left and right, and then I'm subtracting y. All right, so there's that first example. Let's take a look at another one. And you can see here there's a different pieces of information that we know. So for each one of these problems, you just kind of have to problem solve. You have to use what you know, figure out what you can, and then go from there using the equations. So write the equation of the hyperbola centered at -1, 4, a equals 2 and b equals 3, and it has a horizontal transverse axis. Graph the hyperbola. So first, just to remind you, a is half of the transverse axis, and b is half the conjugate axis. So basically, I know the transverse axis is horizontal, and I know half of it is 2. So from here, I think I've got enough information to draw the graph. So I put the center at -1, 4. The transverse axis is going to be double this number, so it's 4 units across there, and I know the transverse axis goes horizontally, so that's 2 units to the left and right of the center to be at my vertices. Then in the other direction, half the conjugate axis is 3 units, so I go 3 units above and below that center. And then using those 4 points, I draw my rectangle, draw the asymptotes, and then since the transverse axis is horizontal, I know it's going to open left and right. And then from there, I can write the equation. Since it opens left and right, the x term is going to be first and the y term second. The center's at -1, 4, so x minus -1 goes there, and y minus 4 goes there. In the x direction, the stretch is 2, 2 squared is 4, and in the y direction, the stretch there for the rectangle is 3, so 3 squared goes right there. And there's the equation for that hyperbola. All right, let's take a look at one more. Here we go. Let's say we know the following. So we've got a hyperbola that has foci at 1, 6 and 1, -4, and the slopes of the asymptotes are plus or minus 3/4. So we're going to write the equation and graph the hyperbola. So let's start with, what do we know of these, a, b, and c? We don't know a or b really yet. We can figure that out soon, but I think it's easier to figure out what c is because I can look at how far apart these two foci are. So these two foci are 10 units apart. So c is going to be half that distance because the center is like directly in between these 2 points. So the distance from the center to one of these is 5. And then I don't know anything about the eccentricity, so I can't do c over a, but I do know something about the asymptotes. And if you think back to what we know about the asymptotes, I know that they have a slope of 3/4, and I know that the slope is equal to a over b, because this opens up and down. If it were left and right, it would be b over a, but it's a over b because I know the foci are above and below each other. Now, does that mean that a is 3 and b is 4? Well, not necessarily. It could be 6 and 8 or 9 or 12 or anything, any combinations. But what I'm basically going to do here is I know it's something like these. But I also know that a squared plus b squared needs to equal c squared, which is 25. So what I'm going to do is I could, set up a system to solve this, but really all I need to do is I've got a few guesses here, and all I have to do is plug in this first guess. Does 3, 4 give 25 here? Well, yeah, 3 squared plus 4 squared is 5 squared. That's a famous Pythagorean triple. So that does confirm then that the 3 over 4, a is 3 and b is 4, is actually correct. So that's how I can determine that a is 3 and b is 4. And then from there I can draw my hyperbola. So the foci here are at 1, 6 and 1, -4. The center is halfway in between them at 1, 1. And then a this time is actually vertical because the foci are aligned vertically. So 3 units above and below the center. And then b is 4, so I go 4 units to the left and right of the center. I then use those 4 points to draw my rectangle, draw the asymptotes to the corners of that rectangle, and then I draw my hyperbola curves within those dotted lines, and I know they're above and below each other because the foci were above and below each other. Now, to write the equation for this, first thing you have to be careful of is, since this one opens up and down, the y term is going to be first and the x term second. Since the center's at 1, 1, that's y minus 1 and x minus 1. In the x direction, that's a 4. 4 squared goes underneath the x term, and in the y direction that's a 3, so 3 squared goes underneath the y term. So for each one of these problems, you can see there's just a different set of pieces of information we know, and then the way you piece together the rest is going to be a little bit different each time. So it's a little bit of problem solving, draw what you know, use the equations you know, and each problem is going to be a little different. But give that homework a try, and of course, let me know if you have any questions.